Hello students, welcome to Well Explained. Today I am here for class 9th physics chapter 1 motion. What is motion? When this term comes to our mind, motion, at once we say something moving. But how come can we know that something is moving or not moving, or it is at rest? That the motion of an object is perceived when its position changes with time and with respect to a stationary object. Or in other words, we can say a body is said to be in motion when its position changes continuously with respect to a stationary object taken as a reference point. As you can see in this picture, there are vehicles moving on the road. There's a school bus, car, and a van. These are moving. How come we can know about this कि जैसे ही ये अपनी position change करेंगी. The stationary object in this picture are the buildings, the electric poles. They are the stationary object. And जैसे ही अपनी पोजीशन चेंज करेंगे तो आप देखेंगे कि जैसे बस इज in front of the first electric pole. After some time it will be in front of second electric pole, and after some time it will be in front of third electric pole. This means that the bus is moving. This shows motion. So what is motion? A body is said to be in motion when its position changes continuously with respect to a stationary object taken as reference point. Now, motion in a straight line. To understand the meaning of motion clearly, let us take an example. You just look at this picture given below. At position A, the motorcyclist is in front of a tree. After some time, it is at position B, but there is no tree in the picture, and after some time, it is at position C. So we can say this motorcyclist is in motion. Some other objects show different kinds of motion, such as the motion of swing, motion of merry-go-round, hands of a watch, pendulum of a clock, and many more. The hands of a watch. There are three hands of a watch: the hour hand, the minutes hand, and the seconds hand. We can easily see the motion of the seconds hand because it moves very fast, whereas it takes some time to notice the motion of the minutes hand, and a little more time to make in notice the motion of the hours hand. Got it? आज तीन हाथ होते हैं, मिनट, आवर्स एंड सेकंड्स. सेकंड हाथ का हाथ जो है, सेकंड की जो सुई है वो बहुत तेज घूमती है, तो उसका मोशन हमें बहुत जल्दी नजर आता है. मिनट्स की सुई थोड़ी धीरे, तो उसका मोशन थोड़ी देर में समझ में आता है. और आ हैंड और भी धीरे मूव करता है, तो उसका मोशन पता करने के लिए वी हैव टू वेट अ लिटिल मोर. Now in this picture you can see that this person is sitting in a train. Okay. Direction of passenger motion, you can see motion and rest. Actually, they are relative terms. Suppose we are sitting in a train. So we are at rest if we see the other passengers in the train, because we are having the same position. Our position is not changing. The passengers sitting beside me and in front of me, they all are having the same position after the change in time also. But if we look out the window, we will see that the trees and the poles and the buildings, they all are running. Means actually we are moving, but we see that these things are moving. So motion and rest is actually a relative term. They are not absolute terms. They are relative terms. Now, types of motion. This you might have studied in your class 6 or 7. The types of motion, random motion. Random motion means at random, that means in zigzag path. You can give example of movement of smoke in air. Then translational motion. In translational motion, there are three types of motion. A rectilinear motion, which is motion in the straight line. Then curvilinear motion, it is motion in curve. And circular motion, which is motion in circular orbit. Then comes the rotational motion. Example is the object which rotates on its axis. We can give example of earth rotating on its axis. We can give example of the top spinning. It also rotates on its axis. And then the fourth type of motion is oscillatory motion. Oscillatory motion means the to and fro movement from the mean position. In this, you can give example of a simple pendulum or a swing. In those, there is a mean position and the swing moves to and fro from its mean position. Now, what are scalar quantities? Those quantities which have only magnitude but no direction are called scalar quantities. For example, mass of cement bag is 25 kg. Then specification is about mass and it is complete by writing kg, 25 kg. Similarly, if we say distance traveled by an object is 37 meters, then specification about distance is complete, that we have come to know that it is 37 meters. So mass and distance both are having magnitude, that is the size of the quantity. That is, in case of mass it is 25 kg and in case of distance traveled it is 37 meters. So these are known as scalar quantities. Coming to vector quantities, those quantities which have magnitude as well as direction, both are present, are called vector quantities. For example, if we say that velocity of a train is 50 km per hour along south, we just see it is said 50 kilometers per hour along south. So that means with the magnitude 50 km per hour, there is a direction which is given, that is south, then this specification is complete. So velocity is a vector quantity. Physical vector quantities are represented by a number along with proper unit and direction. As in the above example, you have seen a number is there 50, unit of velocity is kilometer per hour, and there is a direction also mentioned south. So this is a physical vector quantity. These quantities, vector quantities, can be positive, negative or zero also. Now distance and displacement. Distance is the length of actual path covered by a moving body, irrespective of the direction in which the body travels. For example, suppose you can see in this figure which is given, suppose a boy starts moving from his home place A and travels a distance of 3 kilometers to meet his friend living at place B. Then both the friends, they travel along 4 kilometers from B to reach their school at C. So one friend started from the position A, moved a 3 kilometer distance towards B, and then both of them, they join and they move the distance of 4 kilometers to reach their school at the point C. Now the boy goes along the path A, B, C. Initially the boy which started, it moved along the path A, B, C. In this case, the length of the path covered by the first boy is 3 km plus 4 km, which is equal to 7 km. So the distance traveled by the first boy is 7 km. And the distance traveled by the Second boy is 4 kilometer. Clear? Distance traveled by the first boy is 3 plus 4. From A to B is 3 kilometer. From B to C is 4 kilometer. So total distance traveled by the first boy is 7 kilometer. And the distance traveled by the second boy is 4 kilometer. Now here A is the starting point. In the figure that is on the previous slide, A is the starting point and C is the final point. If we want to know the shortest distance between the 2 points A and C, what we will do? We'll draw a straight line AC between the 2 points. Suppose the length of AC is 5 kilometer. So this is the shortest distance between the position A and C of the first boy, and it is called as the displacement of the boy in the direction from initial to final position. Thus, when a body moves from one position to another, the shortest straight line distance between the initial and final position of the body, along with direction, is known as displacement. Distance traveled has magnitude. That is 7 kilometer was the distance traveled by the boy, and that has only the magnitude. That means a number with unit, that is 7 kilometer. It has no direction, therefore it is a scalar quantity, whereas displacement has magnitude as well as direction, therefore it is a vector quantity. If we say what is the displacement of the boy, that is 5 kilometer, and towards which direction, you can see the direction chart is given. The direction from the boy to the school, the position A to the school, is northeast. You can see, if you can see and make out, so north is straight, but as the school is between north and east, we can say the direction is northeast. So the displacement of the boy is 5 kilometer towards northeast. Now the difference between distance and displacement. Distance is the actual path covered during motion of a body. Means it is the total length of the path covered by the body. Whereas displacement is the change in position made during motion of a body. That is the shortest straight line path between the initial and the final position. Distance is needed not to be the shortest path between 2 points, whereas displacement is the shortest path between the initial and the final position. Distance is the scalar quantity. As we know, it has only magnitude but no direction, whereas displacement is a vector quantity as it is always directed. That means it has magnitude as well as direction. Distance of the body, distance covered by a body can never be 0. Whereas displacement of a body can be 0. It can be 0 in which cases? Where the initial and the final position. Suppose that boy in that slide, he moved from A to B, then from B to C, and from C to he comes back to his home. The initial and the final position are his home only. So the displacement is 0 in this case. Now, uniform motion and non-uniform motion. A body is said to be in motion if its position changes with time. So, to describe motion, we should know, number 1, how slow or fast the change in position taking place, and number 2, at a given instance of time, where the moving body is and where it will be in future. So, uniform motion is the motion when a body travels equal distance in equal intervals of time, howsoever small these intervals may be. You can see from this figure, when the body is at rest, means 0 time, from 0 to 1 hour, it traveled 50 kilometers. From 1 hour to 2 hour, it again traveled 50 kilometers. From 2 hour to 3 hour, it again traveled 50 kilometers. Means in every 1 hour, it is moving 50 kilometers. That means the body or the car is moving with uniform motion. Now the distance time graph of a body showing uniform motion is always a straight line. You can see in this graph, distance is taken along the y-axis and the time is taken along the x-axis, and this line is showing, this OP is showing the uniform motion of a body. Now coming to non-uniform motion. A body has non-uniform motion if it travels unequal distance in equal interval of time or equal distance in unequal intervals of time. That is, अगर वो हर equal interval of time में means 1 hour, हर 1 hour में unequal distance cover कर रही है, या equal distance means it is moving 30 kilometers in different intervals of time. The interval of time are unequal. Then in both the cases, this is known as non-uniform motion. For example, if a car covers 30 km in first hour, 60 km in second hour, 70 km in third hour, and so on, the motion of the car in this case is non-uniform motion as the time intervals are equal, 1 hour, but the distance traveled is 30 km, 60 km and 70 km respectively. So the motion of a car in this case is non-uniform motion as it covers unequal distance in equal intervals of time. And if we say the other way, suppose a car covers 30 km in 1 hour, then again 30 km in half an hour, then again 30 km in 2 hours. So you can see the distance covered is same, but the time intervals are different. So this is also a case of non-uniform motion. Other examples of such type of motion are the motion of a train and freely falling body. You can see if we drop any object from some height, the motion of that object is non-uniform motion. Distance time graph of such motion, that is non-uniform motion, are always a curved line. You can see from the picture. That's all for today. We'll meet in the next class. Hope you understood. Thank you. Thanks a lot. Have a nice time.